All right, good morning everyone. Thank you for coming to today's session on dragging your identity management system out of the dark ages. My name is Ryan Newington. I'm the manager of a team called Identity and Device Solutions out at Monash University. And I'm here to tell you a bit of a story today about how the university's moved from a legacy Fortran-based identity system to a modern platform for identity management. Just to set the expectations so there's no disappointment, I'm not going to be doing any Fortran demos. I don't know Fortran. If I did, I'd probably be working for NASA on the Voyager program or something like that. But we'll be having a look at FIM in depth, and we'll have a look at the challenges involved in undoing a legacy implementation. But what you'll learn here today, I guess, isn't just applicable for large organisations or even education. Or coming from very, very old systems. They're concepts and practices that we'll be able to use equally well in any FIM deployment. So at the end of the session, you'll have some tools. So I'll post a link to a lot of the tools that we talk about during the session today. And hopefully you've got something to take back to your organisations and look at in your FIM implementations. So we're going to have a look at 4 things today in our session, and those familiar with, I guess, software development might recognise this pattern a little bit. We're going to cover over design, development, deployment, and testing phases, and how they translate to an IDM implementation. And we'll see the tools and patterns that you can use throughout your own implementations. Well, before we start, I'd like to set a little bit of context about where these learnings have come from. So Monash University is one of the largest in Australia. It has over 200,000 users. There's 20,000 groups, 600 org units. We manage 180 email domains and teach over 900 courses. We do that in 6 countries with students of 170 nationalities. So as far as identity systems go, you kind of get the feeling about the complexity that's behind all of this. It's one of the most complex sort of environments that I've seen. And the IDM system is responsible for ingesting that complexity and producing our managed identities. So we bring in data from our SAP HR system, our Callista student management system. We've got some SQL server databases that have some other identity information in them. And we digest that and we create identities and push them out to our Active Directory, to Office 365. We use Google Apps for collaboration. And we've got an Oracle LDAP directory that a lot of our applications are dependent on. And all this is underpinned by a system called CRUX, Central Registration for Users on VAX. So back in 1983, when the university bought its first computer, this was it, the VAX 11750. Some Fortran code was written at the time to manage the user accounts on that system. There was only one computer at the time, and this was it. But as the university grew, a number of computers start popping up. We bought a few more VAX boxes and mainframes, those kind of things. And CRUX's role grew and became more and more important to the university. By 1992, the university had grown considerably, along with it its IT requirements. So workstations started appearing on desks. The year of the network PC, file servers, print servers started popping up. We needed a way to manage user accounts and provide access to those things. So CRUX was extended to do that as well. So in 1992, there was a time for an upgrade, and we replaced it with a DEC Alpha device. Same code, it evolved over the time, but we've put it on this box now. The sad thing is, that box that you see there today is still the same thing that runs the university's identity system. So I go to work every day praying that it doesn't fall over. We have had to order parts for it on eBay before. It's probably the single thing that keeps me up at night. So in 2013, I took over the identity space and we embarked on a project to replace CRUX, and we chose FIM as a product to do that. So we're in the final stages now. We're in our testing phases, and we're scheduled to go live over the Easter weekend next year. So let's have a look at how we did this, how we got to that point. Some design considerations before we do. So I talked about the complexity in the organisation before. Whatever product we chose, we needed to make sure that we could continue to support that complexity. It wasn't going away. The university's buying campuses, selling campuses, spinning up new research partnerships. There's change happening in the organisation all the time. If anything, it's getting more complex, so we needed a way to be able to support that. Performance was important. We're talking 200,000 user accounts, many groups. CRUX works in overnight processing. So one of the terrible things at the moment, a new staff starter may not get an account for 2 or 3 days after they actually turn up at the office, because all these things have got to run. So we wanted to really turn that on its head, and performance is really important there. and being codeless. In our Fortran code, and as you can imagine, we stopped knowing how to do Fortran quite some time ago. So to work around it, we just started writing scripts around the outside of Crux. Perl scripts, Python scripts, Bash scripts. At last count, I think there are about 600 of those. So it's this hugely complex beast. And anytime we need to change a business rule that's written in one of those scripts, we've got to get a developer in, we've got to untangle that mess and work out what to do. But our identity teams are normally run by systems administrators and systems engineers that aren't developers. So we wanted to be able to manage our complexity and manage our business rules in a way that allowed those systems admins and engineers to be able to do that without needing to bring in external developers. So now we have a bit of context about where this story's come from. Let's start looking at the process of how we move into our design approach. So the very first thing we need to consider is our business rules. So our business rules are what combine with our identity data, our information about people, about org units, about roles, to form the managed identity that we're custodians of. Without accurate business rules, what comes out of the identity system just isn't going to be correct. So it's important to spend as much time as necessary getting these right. How each organisation approaches this is going to be a little bit different. We might have a team of BAs who can go out there and talk to their business and understand their requirements. It might be the job of the IDM architect or even the engineers to have some conversations to understand. But however we do it, and particularly when coming from a legacy environment, there's one thing that's really, really important to do. I could run an entire session on business rules and bore you all to death, but I'm only going to focus on one key thing here. And it's very important when migrating from particularly a very old system. And that is, if your current identity system was doing its job perfectly, you wouldn't be considering replacing it. So don't take it for granted that just because the old system does something one way, that it should be done the same in the new system. You can ask yourself, is it really a business rule? Or is the old identity system, did it force the business to operate that way? Maybe the system couldn't handle it any differently, so the business adapted around a technical limitation. And the reason it's important to challenge these sorts of things is going to be quite common to find it's actually really difficult to implement or replicate what the old system did, especially when you're moving out of an era long gone of when programming principles were very different, information management was very different, IT looked very different. So I'm not saying that everything has to change, quite the opposite. A lot of what is being done today is going to be relevant and important for business continuity. But I guess you rarely get to have the opportunity to transform an organisation's identity stack, and you probably don't want them too often either. But make the opportunity count. You might actually find you can simplify those business rules for both yourself and the organisation. I'll give you an example. A couple of months ago, I was going through our business rules, and I came across one that said something along the lines of, we need to be able to have an account that can't log into any workstations, that can't print, that can't log onto the internet, that can't log into Active Directory, that can't log into this, can't log into that, but they need to be able to access their email. And so I thought about it for a while. The cogs turned. And it was something that struck me as a really technical requirement. It didn't really make sense. I had no idea how I was going to do this. We'd be looking at setting up group policies to lock things out. So we went back to the business and said, what you've given us here is a technical requirement. You've told us you want an account disabled, you don't want access to this, you don't want access to that. What do you actually want? What do you want to do? Tell me what the scenario is that you want to do. So we had that conversation with them, and we found out what they actually wanted was to be able to have an email address like studentinquiries@monash.edu. And there's a team of 20 people that go and sit there and respond to those emails, and any of them can access it at any one time. But they didn't want other people to be able to, didn't want those users who had access to the mailbox to be able to use that account to log on to other things. So fair enough. So what they're after was a shared mailbox with delegate access. But because the old system actually allowed the way that they used to do it, that's what they asked for. But what they really wanted was something that was a lot simpler than what they'd asked for. So by challenging it, we got to understand that, and we've created a new resource in FIM called Shared Mailbox. It has an attribute called Delegates. We had some names on that, flows out to Google. When they log into Google with their regular account, they've just got a drop-down list of mailboxes they can select from. Much easier than thinking about how do we block access to all these things and still let them log in. So a better result for them and a better result for us. They don't have to worry about passwords and all those kind of things. Once we understand our business rules, we need to look at our identity data and how the two combine to make our managed identities. We need to not just look at the data itself, but we've got to plan how we're going to use that data. So these are my 4 identity data operations. In any IDM system, we do these 4 things, no more, no less. By approaching our design through this particular lens that I'm going to show you, we can define very clearly what the data is, where it needs to go, how it's going to get there, and what you need to do with it. So let's look at the first one, data transfer. Simply the act of moving data from one system to another. We have a source system, some sort of transfer mechanism, and a target. Pretty straightforward. It's the simplest of the 4 operations, but it's so important to get right because without them, we can't do the other 3. So we need to ask ourselves, how do we connect to those systems? What data needs to be transferred? How much of data needs to be transferred, and how fast does it need to be? And once we have those answers, we can start thinking about performance, server sizing, how many servers, what sort of databases we need, and what sort of speed we need on the disks. Do we need Delta capabilities? We start talking about connectivity. Are there built-in MAs in FIM that can do the job? Can we use custom MAs? Do we have the access rights that we need to transfer that data out? We need to understand the direction of flow of information. We ingest a lot of information from some systems, but sometimes we have to contribute back to things like the HR system. Does it need to know the username, the email address of the person? And most importantly, can we actually get all the information we need to be able to fulfill the business requirements? Once we've done that, we can have a bit of a think about transforming that data. So not all systems record the same information in the same way. No doubt in our discovery work, we're going to find that some data just isn't in the right format for us to consume by FIM. So if we have a look at some common scenarios, in an SQL database, might have a 0 or 1 in a table. When it gets to FIM, it needs to be true or false. Pretty straightforward, happens quite a bit. Dates, every system I've seen uses a different date format. Day, month, year, FIM service needs it in the ISO 8601 format, and in UTC time to be able to process correctly. We have a database that holds ASCII 7 information. It's all in uppercase for the person's display name. We don't want their name screaming at them when they log onto their PC. Hi, Ryan. So we need to title case that coming through. When we look at SIDs, FIM wants them in binary formats, other system wants them in SID string formats. So transforming is the action of taking the same piece of information and presenting it in a way that's appropriate for the target system. We're not changing the information itself in any way. It's still a date, it's still true or false, it's still my name, it's still the same SID. The information stays the same, the presentation of it is different. Creating data. So we do this a lot in our systems. Usernames, email addresses, role information. Creating it is making something that doesn't already exist. It's distinct from transforming because in creation we normally use some of the data we already have to make something new, but we've actually made something new in the process. So we might take first name and surname and create an email address, or a contract expiry date and we want to drive an account deletion date. But it can be confusing sometimes to think of, are we creating or are we transforming? And there's one question that we can ask to work out which is which. And that is, if I change this data in whatever way, be it transform or create, can I still call it the same thing? If I have the expiry date and I convert it to ISO 8601 format for the FIM service, is it still the person's expiry date? Yes, it is. I've transformed it. But the example where I said contract expiry date and we've changed it to account deletion date, I can't call it the contract expiry date anymore. It now represents something else. It's a new piece of information. And why is it important to distinguish between the two? We transform data normally in transit from one system to another. So if I was going to transform my contract end date into an account deletion date, I've locked that in because every user in the system will have that same transform applied. What if the CEO rings up tomorrow and says, hey, Bob's finishing on Friday, but I need him to keep his access till for another week. We can't do that because we've locked it in. It's part of that transfer mechanism. Whereas if we're creating information in our identity system, we always should have the ability to override that. And it's much easier to do so when we're creating information on a case-by-case basis, not transforms, which generally applies to all the information that we're passing through. The last thing we need to do after we've done our transfer, our transforms, and our creating of new information is we need to look at that data and we need to act on it. So common examples are we might perform a provisioning action based on if we have a provisioning flag. We use a really simple way to tell if something's ready to be provisioned. We've got an attribute called provision to Active Directory, provision to Google. If that's true, an action kicks off to perform the provisioning. When it's set to false, that account gets deprovisioned. So an example of an action. Maybe we might send an email to a user to say, hey, your account's going to expire in a month. If you've got any paperwork that you haven't done with HR, if you're expecting to be renewed, you need to get on that now. So we're looking at that information that's there and performing those actions. So once we understand what our data operations are, we can look at where they fit in our architecture model. We can choose the tools that suit the task best. So if we have a look at, I've got a table here of out-of-box features and what we've done in the Monash implementation. So having a look at transfer. So the synchronization service is the transfer engine for FIM. It is fantastic at doing it. It's my favorite piece of FIM. It's extensible, it's quick, if you follow some basic principles. But it's very, very good at what it does. It provides us a bunch of built-in MAs that we can use, and if they're not suitable, we've got custom MAs, we can write them ourselves, or we can go out to a partner and we can obtain those. So we use all of that in the Monash implementation. We use it very, very heavily. The sync engine is our most important piece of our identity system because we have so much coming in. We're using the ADMA, FIM service MAs, a couple of built-in ones. We've written a couple ourselves, and we've obtained some third-party ones for Google and things like that. When it comes to transforming data, that process of when we're transferring, I always get confused, when we're transferring data, FIM allows us to hook into that transfer process through management agent rules extensions. We can write them in .NET. We can make them literally do anything we want. Alternatively, there's if you're using declarative provisioning, you'll have synchronization rules in the FIM service that you can use to change that data as it's coming through as well. If you think back to the slide where I said we had our three requirements around managing complexity, performance, and codeless. So we investigated declarative provisioning when we were first doing our design. And we found it wasn't suitable for us for a couple of reasons. The complexity part. So what you can do in declarative provisioning with workflows and those kind of things can be a little bit limited. The performance part, so EREs and DREs can triple the size of your metaverse. So we had 200,000 user objects. We're talking about having 600,000 objects now. The scope sync rules really didn't give us the ability to have that complexity managed that we needed. So we needed to do something else. But we had our original goal of not wanting to have any Monash-specific code in our environment. So I wrote a component called the LithNet Universal MA Rules Extension. And what that is it's a UI-based editor for a file that can be loaded by FIM through a rules extension DLL that allows you to declare all your transform rules in a UI. You don't need to write any code. There's 30 or 40 of them out of the box. I actually just released it today, so you guys will be the first ones to be able to get your hands on it if you want to there, and we'll see it in the demo. Creating information. So out of the box, we have FIM service workflows and the FIM portal. We use the FIM portal extensively for our manual object administration. That's where we go to change any data, create new accounts and those kind of things if we need to do it manually. FIM service workflows, again, there's a bit of an overhead in the workflow engine. If you're having a lot of user accounts, particularly a lot being created at the same time. Every January, we take in a new run of students, 10,000 new students within 1 hour. They'll get their offers and they will all register and hit this site at one time. So we need to be able to support big bulk operations like that. And FIM service workflows kind of didn't really make the cut for us there performance-wise. So what we do is another component we wrote called the LithNet ACMA Codeless Business Rules Engine. ACMA used to stand for Attribute Constructor MA. Because that's what it did. It made attributes. So it was a custom management agent. It's got its own database. We push information out. It adds usernames and email addresses and all those kind of things and contributes it back. It does a whole lot more now, but we still call it ACMA. And we'll see that in the demo as well today. Acting on information. So again, our FIM service workflows are there for us to act on information. We can write metaverse rules extensions to control provisioning, deprovisioning, our object deletion rules. We can extend all that, but again, we're back in .NET, and we can also do that with declarative provisioning. I've talked about the reasons why we don't use that in our environment. We do use some FIM service workflows, mostly for things like email notifications. New starters get an email. People on their way out will get an email. Soren Grantfeld's Metaverse Rules extension, however, is the piece of the puzzle that we use to control provisioning. So it's a Metaverse Rules extension, plugs into the sync engine, and it just has an XML file where we can say, when these conditions are right, provision this to Active Directory. And it's, again, really, really easy for us to modify, no code required there. We do have something we wrote. There's a piece that I think is missing from the FIM product, and that is it's great at creating accounts, but how do you get those accounts into the hands of your users once they've been created? So I talked about the 10,000 new students we get every January. So we wrote a custom account activation portal. So what happens is ACMA will generate a secure token. It'll pass it off to the FIM service. FIM service puts it in an email. It says, "Hi Ryan, welcome to Monash. Click this link to activate your account." Goes over to the account activation portal. It will ask them to set their password, which it goes and sets in AD. It will ask them to register for SSPR, which it goes and sets against the FIM service, and they're ready to go. We haven't had to get involved with them at all. The front end part of that is Monash specific, and we haven't sort of released that as open source. The back end, however, is available. It's another component called the LithNet Resource Management Client, and there's actually JSON and REST web service that we've written to talk to the FIM service. So you can do that from Linux and a whole bunch of other operating systems as well. So let's have a look at our identity data operations in practice. If I can remember which button I'm on. Okay. So I have my sync engine here. I've got two MAs. I've got ACMA as one of them, and I've got my HR system, my pretend HR system, which is just an SQL server. So I'm going to go hire a new employee through the very complicated process of putting an entry in my fake SQL table. I'm going to add myself in. Didn't want to press F1. I'm probably going to do that a lot. I got this laptop shortly before I came here, and it's got the most annoying keyboard in the world. All right, so I've just added myself and put an end date. I should probably make it next year, hey? So I'm going to expire on the 1st of January next year. Now, a couple of things to note about this. The end date is not in the FIM service date format. I'm going to need to change that. The employee ID is an integer, and in FIM, I've got it defined as a string, so I'm going to need to change that as well. So this is where UMA comes in and can help me. So let's have a look at my rules here. So this is the UMA UI. It's really, really easy. We can add a new transform. It asks us what type of transform we want and allows us to configure it. There's heaps in here. Everything you can want to do with the string, you can do it. You can look up CSV files, XML files, regular expression, find and replace. It's also got a lot of the built-in things that everyone has to do in FIM, but for some reason Microsoft didn't write the support to do it, like setting the user account control attribute to disable someone's account, the little bit mask in there. So there's built-in support for that. Converting those portal group strings, security, universal, distribution, into the number that needs to go to Active Directory. It's in there, it understands it, and it's ready to go. So lots of stuff in there. Removing diacritics, so accents on names for making email addresses. All the stuff that you need in today's identity world. If there's something missing, please let me know. Very easy to add it in. But I've created a transform here called database date to FIM service date. And I've listed the input type as a custom string format, and I've matched the string format to what's in the database there. I've said that the time zone's in Brisbane time. Optionally, I can add a calculation to this. I might want to add some days, months, years, whatever. And I specify an output type, and here I'm saying put it in the FIM service date string format. I don't need to specify an output format because it knows what the FIM service date format needs to look like. And my output time zone is UTC. And I have a little test section down here where I can put in a date or a value, and this is going to come in as a string. And I can just see what the transform's going to do. And we can see it spits it out there in that the correct format there. So it's done that work for us. ToString transform, so this is a data type converter. UMA, the Universal MA Rules Extension, has a built-in ability to really coerce values where FIM doesn't necessarily do it itself. So if you put in a base 64 string and you say convert it to a binary, it'll work that out. If you put in 0 or 1 and you want it to be a Boolean value, it'll work that out as well. So you don't really need to think about it. As long as it kind of represents that value, it'll find a way to get it there for you. So how do these work when it comes to the sync engine? So if I open up my MA, have a look at my attribute flow, and I have an advanced flow rule here for end date. And all I need to do, everyone see that? My source attribute name is end date. I use what's called the transform operator, the two greater than signs, db date to FSD, which is the name I gave the transform, and put it in employee end date. So take the end date, pass it through to transform, put it in the employee end date. I can chain transforms as well if I want. It doesn't have to be one. If it wasn't a string, I could add ToString in the chain as well. So take the end date, pass it to the transform I created, ToString, and then in the employee date. So it's very, very easy, and that's all you have to do. So you define your transform, and your rule comes from the name of your flow rule. UMA will know what to do when you put the flow rule name in there. So let's bring that data in. So I can see it in my connector space here, and it's in the database date format. Let's do a synchronization now and see what happens. So I've got an update here, and I can see I now have the employee end date in the right format. If you notice, the other thing that happened here was I got an outbound synchronization to ACMA, so a provisioning action has taken place as well. In the Operations tab, you can see I've got the FIM MRE, that's the Grantfeld Metaverse Rules extension there. And this is the file that we load up in there to perform the action. So all I need to do is specify the target management agent name, which is ACMA, the source and target object types. And you see in the action element, we've got the action of provision. For our initial flows, in our DN for ACMA, we need a GUID. So we've got a flow type of GUID in there. And as far as conditions go, well, let's try that again. I only want to perform this action if the employee ID attribute is present. So with a few lines of XML, we can have that provisioned out to our ACMA system. So let's have a look at how ACMA works. So I mentioned before it's a database. It has attributes and object classes and bindings. They're the same data types as the FIM service, the FIM sync engine, works in the same way. You'll notice the transform engine is in ACMA as well. So this is where we can use the same types of transforms that we've got in UMA to apply to our data that we use in ACMA. But the power of ACMA really comes from these things called constructors. So what we can do is very, very easily say, right, I want to define an email address for this user, or for all users rather, I should say. So create a new constructor, I give it a value, an ID, and I say what attribute I want to build. In this case, it's male. Now, ACMA looks at its own schema. It's got a bit of IntelliSense built in. So you can say, take the given names attribute, add a full stop, then I want the surname at msftignite.com.au. And what it's going to do is when a user gets exported, ACMA runs all these rules. And it will run this rule and say, right, I need to make an email address for this user. And it's going to take the given name, full stop, surname, and provide make the email address. I can also apply transforms to it, so maybe I want an all lowercase email address. I just put that in there. But I may not want to generate an email address if the person doesn't have a first name or surname, because that's going to be a little bit weird. So we've got these things called execution rules. And you can create execution rules to run on whether an object has changed, whether an attribute has changed, whether it's present or has a particular value. So we can say in here, given names is present. And surname is present. And I change this group that these rules run in to an all group, which means all those conditions must be true for this constructor to run. We'll do one more very quickly, and this is to set an end date. Deletion date. So we want to know when to get rid of this user. And I'm going to take the contract end date that we had, and I can even apply transforms in here. And I've got a transform called toEndDate. And what that is going to do, if I have a look over here, is take a date and add 12 months to it. So this is a good place to use date calculations, is inside ACMA, because it's designed to use for transforms. So if I save that, I can now export my object. And again, during export is when ACMA's rules run. So it's the only time it's going to know what's changed and those kind of things. Upon import, all it does is read it from its own database and give it to the FIM sync engine. So imports are very, very fast. We get about 120 objects a second on import. Exports are fast too in comparison to some of the other MAs out there, but probably about 40 or 50 in a properly tuned environment objects per second. So that's exported, so I'm going to import it now. Come on. Don't make a fool out of me. There we go, so we've got some updates. Let's have a look what ACMA's contributed. So we have our delete date now. We have our mail. There was also a constructor in there for username that's built a username for me and made sure that it's unique. RNEW0001. I've told it to grab the first letter from the first name, 3 letters from the surname, and add a 4-digit number on the end, and it's gone and done that. So it's very, very easy to start creating information using ACMA. Very easy to transform it using UMA and acting on it with our Metaverse Rules extension that Soren Granfeld wrote. Where's my clicker? Right. So in IDM implementations, rarely do we get something right on paper, build it, call it a day, it's done, it's working. We build, we test, we experiment, we get it wrong, we wipe it, we start from scratch. And we need a process that supports this mechanism. So FIM's such a great platform in that it's so extensible. What it doesn't do out the box, we can write in MAs and rules extensions, workflows, we can make it do whatever we need it to do. But keeping track of all these customizations can be quite daunting. And if you have a complex identity system, and I haven't seen one that doesn't have its complexities in its own way, we need a way to track and manage change, not just through the development cycle, but also once we have a working product in production. Businesses change, and along with them, so do their business rules. So we need to design a process that can work both in the development part of the implementation, but also once it's in production as well. So how do we manage change reliably? Well, the first step is we've got to break our design into components. So how do we define a component? Anything that can be independently deployed and versioned whether it be a piece of code, a configuration file, or a combined set of configuration items that comes together to perform a feature, is a component. So the sync engine itself, that's a component, the FIM service, the FIM portal. If you've got any custom MAs or using ACMA or UMA, they're all components. They've got a defined version. The vendor or the developers put that on there for you, so you don't have to worry about it. And they're deployable binary code components. So they're probably the easiest of the lot. Next thing we think about is configuration. So we all have to change our fimservice.exe.config file and put our mail server details in there so it can send emails, right? That .config file, that's a component. You can put an XML comment up the top with the version number in it and deploy it to all your FIM service instances. Every MA is a component, not just the binaries, but a separate component for the configuration of all the MAs. So we can see here we use and abuse the description field to keep track of the version of each of those MAs and the configuration, so we can track it very, very easily. You'll notice one under here, _FIM sync engine version. This is a dummy MA, it doesn't do anything, doesn't have any connectors in it, it doesn't have any run profiles. We just have it there so we can use the description field because that's the version of our metaverse schema. So we can keep track of that and see it at a glance. When it comes to the FIM service, your components are really your features. So the MPRs set some workflows that make up, for example, the SSPR functionality. That's a component. They're all bundled together and they can be versioned. The schema in the FIM service, the user interface, they can all be their own components. They're all discrete, they're all versionable. But how do you version them? I like to use a custom resource type called a changelog entry. If you visit my blog, which I'll give you the link to a bit later, there's the code here for how you can deploy this. But we have this in our environment. It's super simple. Just has the component name, what version that's at, and a description. So I'll show you how you can set that up in one of the demos. As painful as it can be, we all know the importance of documentation. And I can't stress enough that the documents need to be authoritative for each of these components that you build. Each component has a matching component design document. If you can, keep all the docs in a repository like TFS or Git. If you have those in your organization. If you don't, you can get a free Visual Studio Online account from Microsoft, free for 5 users, where you can do this in there. They're not just for code. You can use them for documents, binaries, whatever you want. And they're great because they keep a version of every change that was ever made to that particular item. So you can always go back in time if something were to break and go, well, what changed between this and that? And if they're text-based files like XML, you can do comparisons inside the system and it can show you exactly side by side what has changed. So they're very, very, very powerful. And lastly, automate. Script everything you possibly can. The more complexity, the more components you have, the greater the risk that if you're doing it manually, something is going to get missed. We've done this a few times ourselves, unfortunately. There are also 2 camps in the world of FIM people. Those that prefer to configure the FIM service and export the config and put it in others, and they kind of have a master FIM portal to do that. And the others that say, we'll start from script and deploy that into all your environments. I'm a big fan of the deploy from script methodology. Certainly we need to use the UI to get it right and make sure our sets work and all that, but once we've done that, put it into some configuration and some scripts and allow those to be deployed. And I have a tool to make your life a lot easier when it comes to that as well. So once we've developed our components, we need a robust way of deploying them. And this is where our release process comes in. This is where we take our configured components, we bundle them together, and we deploy them into an environment. We're not talking about big software releases or scary ITIL terminology or anything like that. This is just a mechanism to make our lives easier. Very simply, a release is each one of your components snapshotted at a specific version in time. The release has its own version number. So you might say in release 1.5, I've got version 1.1 of the Active Directory MA, 1.5 of the FIM server schema. Each release should have a document as well. detailing what those component versions are. You might want to include some reader-friendly notes about maybe some bugs that were fixed or known issues or new features that have popped in there. And you can schedule your releases in advance. We do a release every Friday, every 2 weeks. Sorry, Friday every 2 weeks. And that allows us to plan what sort of features we're going to develop, what release are they going to end up in. We know in 12 months' time exactly what release number is going to be on our FIM environment. We might not know what's going to be in there, but we know there is going to be a release, and we can schedule small pieces and large pieces of work to be done within those particular windows. Make your release version visible. You want to know at a glance what release you're on. Here we've got our FIM portal, and you can see up the top, this is environment dev 5, and we're at release 3.0 in this particular environment. There's no point having versioning if no one can see them, because you won't know what they are. Environments. So release process needs a bit of controlled infrastructure to work. Everyone in this room probably knows it's next to impossible to have multiple people working on the same FIM server at the same time. You can't have someone fiddling with an MA and someone else is trying to get a rules extension working. All you're going to end up with is angry engineers, angry developers. So have one dev environment per developer or engineer, or one environment per component that can be built in parallel. Then we create a dev staging environment, or a master dev environment. This is where all the work done by the developers, or the engineers, I should say, in their own environments gets merged before release. You're going to have a QA environment for testing. Unless you're doing this for some weird sense of personal fun, you're going to have production as well. So how does this work? So I might be working in an environment called Dev 1, and I'm doing some changes on the ADMA. John's working in Dev 2, and he's doing some updates to the FIM service schema. And Renee's on Dev 3, fixing some bugs in SSPR. So we all do our work in those environments. We get our pieces working in a predetermined time before release. We take all of those and move them into dev staging. We increment the version number of each of our components. We do some basic testing and we make a release. So I've picked version 2.5 here with my 3 components that have changed in it. And we push that over to QA once we've done our basic sort of integration testing and we're happy that they're all working together. If QA testing passes, we can move 2.5 into production. If it doesn't pass, it goes back to development. We don't try and fix it in QA. If 2.5 didn't work, 2.5 didn't work. You might wait for your next release window in, say, 2 weeks' time and just try again for 2.6. Or it might be really important that you do get this change out and you might do a point release, 2.5.1 or something like that. But the important thing is release, once you've defined it, don't change it. Probably the most important thing to remember as well, once you have a successful release and you've taken it to production, take that back to all those dev environments. Dev environments by nature, we're changing things, we've got to do a lot of experimentation to try and get something right. We don't know what state Dev 1, 2, and 3 are actually in after all that work we did to try and get something working. So this resets them back to a known state. So for the next release, we're not introducing anything weird into the environment. So it sounds complicated, but I promise you it's not. I'm going to prove it to you. So here I've got a blank synchronization engine. Nothing configured at all, no management agents. And what we can use is the import server configuration, export server configuration tools that come with FIM. I think these are primarily designed for backups, but you can actually use them to move configuration between one server and another. So I've got an export from my dev master here, and I'm going to install it on this particular environment. So it's going to start loading all these management agents. I'm going to provide some credentials. It does this really cool thing. So see how it says you must execute refresh DLL. What it means is go find the hidden window where I've popped the same message up there, and you're never going to see it, and click it so I can continue. Why I have Task Manager open on the side, see this window, please fill in encrypted parameters. This one loves to pop up behind as well, but it doesn't appear in the list of hidden windows, but it does appear in Task Manager. It doesn't do it all the time, just to keep it interesting, as we saw there, but it can hide itself, so be aware of that one. That's only for MAs that have encrypted parameters, not all of them do. If you use Soren Grantfeld's PowerShell MA, is anyone using that in their environment? Yeah? That does it, that's the one that you're seeing there pop up. It's not his code specifically, it's just MA with encrypted parameters. And for no reason, this one didn't pop up behind, it pops up in front so I can actually see it. Our ACMA MA is quite big. There are lots of attributes, hundreds of flows. For ACMA to create all the information that we need in our environment, we've got to make sure it's aware of everything that's in the environment. Now, adding this password information in, I only actually need to do it the initial time when I've got a blank sync engine. Once I've got the code in there, the MAs in there, it actually saves that connection information, that password information in there. When you import the next time, it is going to ask you for the password again, but you can actually click cancel. And then it will say, do you want to use the save connection information that I already have? And you go, yeah, I do, because I don't want to get my super secure password out of the vault and type it in again. Now, one thing I do want to point out here on that we do quite extensively, and that's make use of DNS aliases. So we have 6 development environments. 6 Oracle directories, 6 Active Directories attached to it. To make sure that as we're moving across those various environments, we don't have to take make all the changes to the connection information. We've used DNS aliases, so this FIM service DB in this particular Active Directory points to its local instance. If I use the fully qualified names, every time I come in here, I've got to change them. And it becomes a bit more of a manual process and a bit more prone to mistakes. So if you can use DNS aliases wherever you can, you don't have to change anything at all. So FIM service DB means one thing to Dev 6, which is the environment we're in, means another thing to Dev 5, Dev 4, Dev 3. So it doesn't actually point to the same environment. Our FIM service MA is another really big one. We have basically all our information being presented through the through the portal by the FIM service, and that's our window to what is going on in FIM. So our help desk staff and all our identity staff can go in there and see that as well. So it's a fairly big MA. And it's probably taking extra long today because I'm doing a demo and I'm running a few minutes behind and it's not helping. But it's almost finished, and there we go, we're done. So now I have a fully configured metaverse. I not only have all my MAs, but I have my entire schema there as well. I have my object deletion rules, I have my provisioning configuration, everything has come across. If this was a release process, in 5 minutes, I've taken my config from the dev master to QA, and it's done. So the sync engine, and that's probably 50% of your environment, very, very easy to do. Let's have a look at the FIM service. So I've got a brand new FIM portal here, straight out of the box. I do still say FIM. I know it's Microsoft Identity Manager anymore, but my excuse is that Microsoft still haven't stopped calling it FIM. So when they do, I'll get on that. So this is a blank environment. I'm going to kick off a script that I've got. It's going to take a few minutes to run. And I'll explain what's going on behind the scenes while we talk about it. So who's used the FIM automation PowerShell module? Who's enjoyed using the FIM automation PowerShell module? No one, right. No one does. It's terrible. I hated the FIM service for a very, very long time. Everything I tried to do, it was frustrating. It seemed like it was much more work than it needed to be. And the custom account activation portal that I told you about, I couldn't avoid it. I had to get in there and I had to write some code. So writing that REST API actually allowed me to realize what was going on. The FIM service is actually really, really good. I really, really like the FIM service now, and I realised what I didn't like is all the points where it exposed the FIM service to me, it was actually exposing the guts, the developer side of the FIM service, and that's what the FIM automation module does too. A really good example, let's have a look at, you don't need to know what this script does, but there's 40 odd lines of code there, and all it's doing is getting a user, changing the expiry date, and saving it again, but in the most complicated and convoluted way possible. And these PowerShell things don't actually feel like using PowerShell. It feels like you're programming in a language that's not, PowerShell isn't a programming language, it's a scripting language. So you've got this mismatch of worlds that feels really, really wrong. So guess what? There's the LithNet PowerShell module. And it gets back to just those basic operations. Can everyone see that? So get resource, object type person, account name, Paul W. Set the employee end date to that date that I want there, and then finally save the resource. 3 lines of code instead of 40. I'm not sure why we didn't have this to begin with. So it makes it a lot easier to be able to perform those basic operations that you need there. There's heaps in the PowerShell module. I certainly don't have time to go through it all today, but again, have a look at the link I put up at the end, and there's some material in there that you can look at. There's also a video demo of using those tools as well. So one of the modules that one of the commandlets that the PowerShell module has is a thing called import rmconfig. And what it allows you to do is in an XML file, define what your FIM service config needs to be. So we have one XML file for our schema, where we define our attributes and our bindings. We have another one for our SSPR. So per component, right? We have one of these XML files. And what they look like is this. So the main element is a resource operation. Now this is a type of add or update. So add it if it doesn't exist, update this object if it does. It's a management policy rule, we can see by the type. And what it's going to do is it's going to find the general workflow filter attribute validation for administrator, which is the first one that we go in and disable in any FIM implementation because it's really annoying, and we're going to disable it. So it will check the object. If it doesn't exist, it's going to create it. If it does, it's going to make sure it meets what you've set here. Resource type of set, this is an all changelog entry set. So this is part of that custom changelog you saw. We have a display name of all changelog entries, a description, and an XPath filter / changelog entry. One thing that's missing from that XPath filter is the XML filter crap that you've got to put around every XPath attribute. So the PowerShell module knows that because I've told it it's a filter, so it's going to go and wrap it for me before it sends it to the FIM service. So it keeps my XML nice and clean. I don't have to type anything in there that is standard and is already known. So it makes life a lot easier. So it's gone through and done all that on our system. Hopefully it's finished. It has. And we can have a look now once SharePoint starts up. Come on. You can do it. There we go. I've got some customization now. I've got some new navbar links on the left. I've got my changelog entries. So I've taken a completely blank FIM service instance and FIM portal, and I've applied my configuration on top with one script in about 5 minutes. All I need to do if I want to change something in my environment, I can set this to false if I wanted to, update my component version number, redeploy it to all my environments. Very, very easy. So some things to remember. Use DNS aliases wherever you can. Script everything possible. Know that some things can't be scripted. You can't script that import of the metaverse and get all your MAs in there. So know the limitations of the process. Use version control and make your versioning visible. Again, if people don't see the version, if you can't see the version, it could be anything sitting in that environment. So bring them to the front, make them visible. Testing. another one thing I could do an entire session on. I could probably do an entire conference on testing, but I'm just going to give you a quick summary of how to approach testing in an implementation. 3 types of testing that are important to consider: unit testing, component testing, and end-to-end testing. So unit testing involves a lot of small, independent, repeatable tests that are always automated, almost always automated and script-based. This is where we can test things like the rule that makes the email address works. Perhaps we need to make sure that if a person transitions with attribute X can transition into set Y when that attribute change happens. So they're very, very small, very basic tests that we can script. Invest as much time as you can afford into unit testing. If you're using ACMA, it's actually got a unit test engine built in. For every rule you write, you can write an associated unit test at the same time. We have over 1,000 tests in our unit test engine. The great thing about doing unit tests is you don't need to involve any other systems. You don't need to involve your HR system, your FIM service, or anything like that. You're just testing this really small, very specific things in your rules. So ACMA allows you to define criteria of what passes or fails. The unit test engine actually sends an object to ACMA for processing. You define what that object is. So you might say create a person with a first name and surname attribute, and then have a look at it when it's done and see if it's got the email address there. And ACMA doesn't even know it's processing a unit test. It thinks it's getting objects from the FIM service and processing them normally. So the unit test engine is kind of tricking it. So you know everything you get out of there is reliable. Each time we make a change to a rule in ACMA, we rerun the whole suite of unit tests. Because sometimes if we change a particular value over here, it might have an unintended consequence of something else over there. And the unit testing will expose that for us if we do that. And it happens quite a bit, you'd be surprised. The next one is component testing. So this is where you make sure your components and features are working as expected. You've tested your individual functions and your individual rules with unit testing. Now you need to make sure that together they behave correctly. Component testing is almost always manual. It involves multiple steps. There are cases where if you have lots and lots of unit tests, you can negate the need for component tests. Our ACMA environment is an example. We have almost no component tests for ACMA because we have so many unit tests. If there was an issue, we would see it in the unit tests. But most your management agents, for example, in FIM, you can't really unit test. So how would you unit test your ADMA? You know, there's no automated way to do that. You've really got to go in one by one and check the flows and make sure that you know, the right information is being transferred to and from. So it's a little bit more complicated and requires a bit more time to do. And of course, every time you change the ADMA, you're going to have to go and redo those component tests. End-to-end testing is the last phase. This is where we go back to our original business requirements that the business gave us, and we test the scenarios outlined there. We involve all the systems in the process. Our HR system, our student management system, our AD, our Google. But we can enter end-to-end testing with a high degree of confidence if we've got our unit tests that are passed and we've got our component tests that are passed, because really all we're testing is business scenarios. Mostly interpretation of those business rules. If you think back to one of those first slides where I showed you that we had 200,000 users and all that kind of stuff, the complexity in the environment, right? So what if I told you that in the 3 months that we've had, I think 5 resources full-time doing end-to-end testing, they've only found about 10 defects. We have 1,000 attribute changes that we make in ACMA under 3,000 different conditions. And we've only had 5 defects come through. Because of that investment we made up front in unit testing, we knew that the rules were right before we even got to end-to-end testing. And the benefit of partitioning as much testing as you can into unit and component testing is you get to do it. When it comes to end-to-end testing, you've got to involve your HR team, your student management team, to go into those systems, create those users for you, see if they push out to other environments. It's expensive, it's time-consuming. And if you have a lot of issues, you're not going to see them, and it may be too late. You may put your project in jeopardy. Let's have a very quick look at ACMA unit test demos. If I can find the server. ACMA has PowerShell commandlets as well, so you can add, remove, delete, change user objects. There is a commandlet called invoke ACMA unit tests. It's going to go through my file and it's going to start executing all those unit tests. It's going to tell me whether it passed or failed. There's a detailed log that's coming out the other end that will tell me what actually failed and why. So how do I define them? Again, very simply, they take a minute to create. So I've got a test here called test that an account not containing a bad word is generated. You'll be amazed at the number of four-letter words that you come up with when you take the first letter of someone's name and the first three letters of their surname, combine them together to form a username. There can be some pretty unpleasant results generated there. So we have a list of banned words, and this is just a test of one that is known not to make a nasty four-letter word. So we've told ACMA, can everyone see that? I'm going to zoom in to very simply create a person. It's an object modification type of add. So we're adding a new person object and put these two attributes on it. Surname Smith, preferred name John. So we'll go and we'll pass that on to the ACMA engine. And then we have a validation step where we look and say, if the account name equals JSMI0001, that has passed. Very, very easy to write. Doesn't involve any code. And you've defined very clearly and you can see what this rule is and what it's supposed to be. So we have literally thousands of those. Creating home folder paths even. Again, I only pass in the information I need. To create a home folder, I need a home folder group number and an account name. I don't need to go and expect ACMA to create the account name, provide the first name, surname. That starts getting too complicated. All we need to create a home folder is our account name and home folder group, because that's all that ends up in the path. And so it goes and builds that. So those unit tests will run. We can even see a couple of them there have failed. I did that on purpose so that you could see. But it tells us the reason why. You told me that the username should have been this, and it actually was that, so I'm failing this test. Spits out a HTML report that you can go through those details as well and have a look at. So closing thoughts today, clearly define your business rules, understand your identity data and where those identity operations apply, and use the right operation for the right task. Define and version your components. Have your release process. Wherever you can, invest in that unit testing. It'll pay off tenfold at the end of your project. If you can complete your session evaluations, that would be fantastic, because I have the takeaway resources for you here. So on the link that's going to appear on the next page, you're going to find links to ACMA downloads and documentation, the Universal MA Rules extension, the FIM Service PowerShell, REST API, Soren's Metaverse Rules extension. 2 videos I've recorded on ACMA and the FIM Service toolkits that I've written. So please go ahead and watch those. That'll really do a deep dive and show you how they work. And there's the link. You can follow me on Twitter, send me an email, check out my blog. If you're working in the FIM space, you probably really want to join the FIM team user group. We meet monthly. There's FIM people, engineers, architects, everyone from all around the world. Sometimes Microsoft joins as well. It's a web Skype meeting. And each month someone presents a new topic, maybe something they've done in their organisation or a new tool that they've written. The videos that I've posted on my link are there from my sessions at this group. Really, really valuable if you're working in the FIM space. Highly recommend you get involved there. Thank you very much. Are there any questions on anything we've seen? We've got a few minutes. No? Yes? Hi.
So with your DNS services, do you ever end up running into SPN issues?
Yeah, you absolutely need to set your SPNs as well. So we don't. If you set the SPNs up correctly, then no. If you don't, then absolutely you will. You won't be able to connect to FIM service and those kind of things.
And those servers are in entirely separate AD environments, are they?
Yeah, that's right. Yeah.
Otherwise you get an SPN.
Correct. Yeah, that's right. So each of those dev environments has its own Active Directory. That way we can test password changes and all that kind of stuff without affecting other environments.
Stuff from triggers and
There's so the sync engine you're talking about, is that? Yeah. So by default, there's a WMI thing that you can invoke to run the various run profiles. There are products out there that can automate that process. One of them is from a company called Unify Solutions. They have a product called Event Broker, which will sit and listen for updates in your LDAP directory or changes in the HR system and trigger the appropriate actions in FIM. Other people do use a schedule. So there's Soren has a tool called MA Run Scheduler, I think it is, and that will just sit there and run through in steps. Depends on your SLAs. How quickly do you need to be able to bring those changes in and react to those sort of changes. So we use Event Broker in our environment because we need to be able to pick those changes up and move them through very, very quickly. In some of our smaller environments and when we're testing, MA Run Scheduler generally does the job fine.
so like for picking up changes from your source systems.
Yeah, so for those ones, those ones we do on a schedule. The only thing I know off the top of my head that does the picking up changes from the source system is Event Broker, Unify's product. There may be others out there, but it's the only one I know of. Okay. Any other questions? No? Thanks guys for coming, really appreciate it.